Hello everybody, my name is Sadikasia, PhD student in second year. This presentation addresses the problem of finding a robust and stable shader for a single machine with availability constraint to minimize the total energy consumption. The machine suffers an expected breakdown and follow the Weibull failure function. A joint model of integrating run-based preventive maintenance and production scheduling problem is proposed, in which the sequence of job, the PM time, and the plan completion time of job are proactively determined simultaneously. So, to our knowledge, this is the first effort to establish the practical common model for this type of integrated scheduling problem of production, preventive maintenance, and energy consumption and availability. To do so, the presentation will focus on the following points. First, I will start with the general introduction to the problem. After that, I will introduce you to problem description and formulation. Then I will show you the objective function, the modeling of the problem. In the end, I will finish with the conclusion and perspective. The problems of scheduling have been widely studied for 6 years. In most of these problems, machines are considered available. In a real case, this hypothesis is not always true. In fact, the machine can experience period of unavailability corresponding to a period of preventive maintenance, breakdown, or a change of tools. In general, three hierarchical levels of production management are commonly used, namely levels: strategic, tactical, and operational. The strategic level. This is the formulation of the company's long-term policy and strategy, which focus on the management of sustainable resources, so that they are able to ensure the sustainability of the company over several years. The tactical level. There are medium-term decisions that take place over several months. They provide the link between the strategic level and the operational level. The objective is to produce at the lowest cost to meet the feasible demand with the framework set by the strategic line of company. The operational level is the level of execution of the system. This is used for day-to-day management to cope with day-to-day demand while respecting tactical decisions. A general short and very short-term decisions that determine scheduling and steering. Scheduling occupies a special place in the computerized management of workflow within the enterprise. It's usually to meet points between a hierarchical and computerized system of production and the production system itself. This is the place of the interface between the overlaid demand of the order and the operational part. Production management creates manufacturing order that determine overall what needs to be done in a given period, usually the week. The scheduling consists on providing the sequence of all the elementary operations necessary for the realization of this production order on the production resource, while taking into account consequently resources such as operator, tools, etc. External contract, preventive maintenance, work, the schedule, etc. And existing ones, rest of the preventive work, take in progress, realization, etc. In a long-term schedule, production system is always subject to deterioration with users, which will affect the availability of machine and the stability of the system. Preventive maintenance has proven its effectiveness in industry. A machine should be maintained after it continuously works for a period of time. That so long schedule or reasons should consist of several PM periods, since production and PM operation both occupy the machine running time. The schedule should be planned simultaneously in order to enhance the performance of the system. Except the schedule maintenance, which is deterministic element that would affect the availability of machine. There are other expected interruption, breakdown, other cancellation, new order arrivals, or due date changes that would make the schedule rapidly become unfeasible. In this presentation, we consider the interruption of the machine breakdown. In the recent literature, two new criteria have been brought to the attention of research for this consideration. robustness, and stability. A shader whose performance is exceptional when something enforcing happen is called robust. A shader whose realized shader doesn't deviate for it the initial shader significantly due to dissipation and revision is called stable. So, on the other hand, in recent years, energy demand has grown rapidly and remarkably in the different sectors. More particularly, the industry currently consumes about half of the world energy. Furthermore, there has been a growing concern of the environmental impacts of traditional manufacturing, especially in terms of energy consumption and related emission of carbon dioxide. Besides this, the adaptation of new equipment production schedule could by KU role in reducing the total energy consumption of a manufacturing plant. This presentation addresses the problem of finding a robust and stable schedule for a single machine with availability contract in order to optimize the multi-objective of system, the total of energy consumption, the robustness, and the stability. The machine suffers an unexpected breakdown and flow the wayable final function. Which model for integrating a line-based preventive maintenance PM and the production schedule production is proposed, in which the sequence of job, the PM time, and the plant completion time of job are perfectly determined simultaneously. In this problem, the set of n jobs to be processed in a single machine. Each job requires the fixed processing time and the processing power in a single machine. All jobs are available at time zero and no preemption is allowed. Suppose the machine used to process the job is subject to the failure, and the failure function is governed by a waiver probability distribution with a parameter greater than 1, where the failure rise is proportional as to the power of times. Since the distribution function was described in this high-value waiver, it has been widely used in reliability hazard analysis, failure mode, and effect analysis. Obviously, only then the machine as a function is included in function of time. The system is subject to saturation with users. The PM is needed to be performed. For some other kinds of function, exponential distribution is which has a value is constant. The duration is endured is necessary to perform the PM. This is out of our discussion. For the waiver probability distribution, it's basically to perform the PM during production or in order to reduce the risk in expected machine failure. Thus, in this presentation, the PM can only be performed before starting a job or often finished a job. When we make the initial scheduling plan, note that the PM plan and the production scheduling interrelated with each other, since both of them have impacts of the machine capacity of reliability. So the job sequence of the certain of a PM operation should be determined simultaneously in the initial schedule. In each initial schedule will be placed onto the job floor when each job will be processed according to its specific sequence, and PM will be conducted before some job as planned. Obviously, the unexpected machine failure can't be completely eliminated by PM, and reaction should be taken once of machine failure. In this paper, or on this presentation especially, numeral quiet policy is adopted. The machine is restored or operation condition, but machine age isn't changed. This applies that the machine operator makes just a required effort to return to the machine function before failure, since the minimal repair only needs the small change of the machine, which usually hasn't impact of the procession job. The job are assumed to be resumable. The job interruption by machine failure can be resumed after repair without any additional time penalty. Besides, the shift in resolution policy is adapted, when the machine fails and any minimal of power to require job are posted for official amount of time to just accommodate the short power duration. In order to absorb such unexpected rise, shifting, and stability, we propose to proactively add buffer time until the initial schedule for each job. During execution, the rise of such buffer time will be absorbed, which means a job will be started as soon as possible rather than waiting for its prime start time. It meets the results idle time in the realized schedule. The reason we adapt the policy isn't followed. The idle time is the realized schedule, mean the worst of machine's capacity. The machine is idle during that time even there are jobs waiting for the position beside the machine, which isn't accepted easily by manager of the factory. Since the probability of breakdown can be predicted for a given solution, proactive reactive methods is the object of this presentation to handle this uncertain factor. First, initial plans made at the beginning of the event. Our solution can be divided into three parts, X, Y, P. The first one is the job sequence list. The second one is the PM position matrix. The third one is the position time of each job matrix. I will show you two examples to understand the subject. For the first example, there are 4 jobs to be processed in a single machine. The figure shows the Gantt chart of initial schedule for this problem. As you can see in the figure, in order to absorb the unpredictable rise shifting and stability, we propose to proactively insert the idle time into the schedule. As shown in figure 1, there are some idle time which don't exist in the schedule if the unexpected breakdown are ignored. It means that the planned start time of the job aren't really decided by the job sequence and are severely affected by the idle time inserted. After the initial plan is made at the beginning, the job sequence and the position of PM will not be changed throughout the scheduling horizon. However, the released start time of operation will be charged. For example, if one breakdown happened during job 3, as shown in figure 2, then 1 CM is performed. The job 2 can be delayed and the job 3 and the PM ends delayed because of existence of idle time. The rescheduling policy is quite reasonable in practice since the initial schedule serves as the basic for planning external activity since it will show change and the material procurement. For example, if the released job sequence is different from the initial planning sequence, it will cause a lot of trouble for the material supply system. Since the original material prepared needs to be moved out from the production lines and the new material needs to be moved in, and one job can't be started if the related material aren't ready. I will show you the second example. We will take the same data from the first example, but this time which 1 CM happened during job 3, as shown in figure 4. In order to absorb the unpredictable rise shifting and stability, we propose to actively insert the idle time into the schedule, as shown in figure 3. There are some idle times which don't exist in the schedule and the expected breakdown are ignored as the first example. The multi-objective function minimizes the robustness, stability, and the total energy consumption, which mainly include the energy consumption of machine tools and the common energy consumption. The total energy consumption of the workshop, which mainly include energy consumption of machine tools and the common energy consumption. The total energy consumption is the sum of total procession energy consumption and common energy consumption, which are computed as below. Concerning the precision energy consumption, being the energy consumed by the machine when the operation are being processed. The precision energy consumption can be calculated as below in equation 2. Regarding the common energy consumption, in order to keep the washer environment temperature and humidity Auxiliary facility as well lighting, air conditioning, ventilation, and heating must be used. Energy consumption for this conciliation facility stands for the common energy consumption, which can be computed by the following equation 3. The total energy consumption is the sum of total processing energy consumption and common energy consumption. From the viewpoint of robustness, what really matters is the performance of the realized shader rather than the initial shader. Thus, the expected realized performance of system is used to be robustness measure in this presentation. As for stability, or realized shader should deviate minimal for the initial shader. Thus, the expected sum of absolute deviation and the completion time of job is used to be the stability measure. Our multi-objective function is the sum of robustness, stability, and the total energy consumption. We mainly include the energy consumption of machine tools and the common energy consumption. Concerning the modeling of this problem, the proactive joint model can be finally established as follows. The objective function is found in constraint 10. Constraint 11-12 establish the link between two jobs. Constraint 13 specify the precision time of each job. Constraints 14 and 15 specify the realized completion time of each job. Constraints 17 and 18 answer that each job can only be placed at one position in the sequence, and only one job can be placed at each position respectively. Constraint 19 and 20 set up the binary restriction for X and Y. This presentation addresses the problem of finding a robust and stable shader for a single machine with availability constraints. The machine suffers an explicit breakdown and follows the Weber function. The multi-objective function minimizes the robustness, stability, and the total energy consumption, which mainly include the energy consumption of machine tools and the common energy consumption. We plan to propose a perspective in this problem methods for relevant resolution method that will allow you the better take into account in the maintenance aspects and allows also to solve the big problem.